Hello, welcome back to the course Build Dynamic Simulation Model of Electric Vehicle with the MATLAB. So due to so many requests of step-by-step procedure of developing the simulation model of vehicle, I decided to inculcate one more chapter on solving differential equation with the MATLAB simulation, so that one can use MATLAB to solve any kinds of differential equation in future, not just vehicle model. So let's understand it with one example. There are lots of ways we can have one complete course on solving ODE with MATLAB. There are different programs, commands like the dsolve, ODE 45, but here I kept it limited to our vehicle simulation model and related. So I will explain only how MATLAB simulation can be used to solve the differential equation or ODE. So let's first understand the first problem, and by with example of electric circuit of RL circuit we will solve this manually and then we will use the Simulink model. So you know how to solve the differential equation manually, right? We should have the differential equation, we take apart some di and dt part or dy and dx part and use the rules of differential equation to find out. But what we have to find in this circuit, this is RL circuit, voltage will be known, value of R will be known, value of L will be known. In generally we need to find always current in electric circuit. So to find this current, it will be not constant due to inductance, it will raise exponentially, and at any instant value of current will be different other than the steady state. So by applying the KVL to this circuit, we can solve this circuit or solve this differential equation. But let's first derive the differential equation with the applying the KVL. Then we will have this differential equation, V is equal to IR plus L di by dt. I am not going in deep discussion of electric circuit. We are interested in this differential equation and to solve it. So if you solve it manually, we know separate the di and dt part. So let's do it. So this equation become L di by dt v minus IR, di by dt part separated, and then integrate both sides, and then using the differential equations we can solve it. So it will look like this, and by using one condition that we know, at t is equal to 0 current will be 0, current will rise exponentially slowly, and at the initial condition this will act as an open circuit, as we know that. So from that initial condition we can find the value of this k and final equation, and by solving again this will be I is equal to V by R 1 minus e raised to minus R by LT. This will be our final differential equation, how we solve it. And now when we put the value of time in this equation, we will get the value of current I. Or if we increase the value of time from 0 to certain value, we will have the plot of current I. But this plot can be plot with the help of MATLAB simulation blocks, and this equation can be solved within the Simulink library. So that we need to understand any differential equation can be solved. So which differential equation we are interested to solve is this one, and which result we want, it will be this one, I is equal to V by R. So we will observe this kind of shape in the scope if we do the simulation. Now how simply this equation can be represented in form of MATLAB Simulink library, that we will see. It may be here output is I, we want the current. So the differential term di by dt should be one side, L di by dt is equal to V minus IR is our equation. So let's bring this equation in Simulink model, and we will build step by step Simulink model for this equation. So let's go.